Amanda works for Biomimicry 3.8, which is a consulting firm. Is that what you call yourself now? And she's a material scientist and is going to be talking about factory as forest.
So thank you so much for the introduction, and thank you all for sticking with me on a Friday afternoon. And I also wanted to take a moment just to thank Trisha and Biocene for inviting us here and for kind of squeezing us into the agenda a little bit last minute. So I really appreciate that. My presentation is Factory as Forest, moving the automotive industry from zero footprint to positive impact through biomimicry. My name is Amanda Nummy. I'm a third-year biomimicry student at Arizona State University, and I just joined the team at Biomimicry 3.8 at the end of March, so I'm very new to the team, but I'm coming from about a decade of experience in the automotive industry, specializing in materials, fuel cells, and battery electric vehicles. So this presentation will cover the application of biomimicry broadly across entire organizations, so helping companies perform more like ecosystems. As we know from life cycle analyses, if we look just at product innovation without considering the system as a whole, it becomes very difficult to achieve positive performance. So this means we need to go beyond design of specific products to include considerations for facilities, operations, and communities. And so this presentation will kind of outline how all of that fits together. So first I want to introduce Biomimicry 3.8. They're the global leader in nature-inspired innovation services and biomimicry training for professionals. The 3.8 is a reference to 3.8 billion years of life on Earth that we can tap into as time-tested research and development to think differently about how the challenges we face today and the methodology of how we can look to solve them. So Biomimicry 3.8 is a network of about 150 practitioners around the world offering services in biomimicry consulting, professional training, and speaking engagements. Over the past 20 plus years, a framework has been developed to help companies design and innovate based on expertise of those 3.8 billion years of R&D in nature. About half the work is in product and process design, and the other half covers a mix of the built environment and social innovation. Our work sits at the intersection of innovation and sustainability, and what we recognize is that companies were taking kind of a siloed approach to sustainable innovation, so looking at just a single product or process or facility. So sustainability in nature is, of course, a systems-based and holistic approach, so how can we start to emulate that? And at Biomimicry 3.8, just to level set, we define biomimicry as the conscious emulation of nature's genius, meaning we go beyond simply copying forms and colors to understand the deeper strategies and mechanisms of how nature functions. We view biomimicry with these three essential elements: emulate, ethos, and reconnect, that move beyond just bio-inspired design. Ethos is the underlying ethical philosophy for why we practice biomimicry, our desire to fit in on Earth, and it represents our respect for and responsibility to and gratitude for our fellow species and our shared home. It comes from the belief that humans are one of many species populating the planet, each with their own inherent right to survive, and that our survival ultimately depends on their survival. So within this ethos portion, the practice of biomimicry should lead towards solutions that create conditions conducive to life. The reconnect element reminds us that humans are part of and not separate from nature. So reconnecting is a practice and a mindset that explores the relationship between humans and the rest of nature, reawakening our curiosity and integration into the natural world, revealing wisdom from which humans can learn and gain inspiration. And then the emulate portion, I think probably we're all pretty familiar with. So that just signifies our intent to proceed as is appropriate on this planet, using nature as a model, a measure, and a mentor. Emulation is the action of biomimicry when humans solve problems through bio-inspiration and ultimately minimize our negative impacts on Earth. So by combining these three elements together, bio-inspired design becomes biomimicry. So we can use biomimicry to go beyond net zero to achieve positive or regenerative performance, benefiting our neighboring ecosystem. Ecosystems are generous. They deliver ecosystem services, including those that are beneficial to humans free of charge, and we can measure what's happening in these ecosystems, how much carbon is being stored, how much water is being filtered, and so on. So facilities and communities can be designed to be generous too. We can quantify those ecosystem services from local habitats, giving us scientific, data-driven, and locally relevant approach to understand what it means to be generous and positive. So this includes not only benefits to the neighboring ecosystem, but also the health and well-being of the people in those spaces, which can bring economic vitality to the spaces, the company, and the surrounding communities. So this is the vision of our co-founder, Janine Benyas, that if our buildings and cities could function like the forest next door, if they could capture carbon, filter water the same way that the local ecosystem does, isn't that what a sustainable design could and should look like? So when the forest and the city are functionally indistinguishable, then we know we've reached sustainability. So in biomimicry, when we look to nature as a model and a mentor to learn from, rather than a resource that we extract from, we can collect data to inform our design. With that approach, Biomimicry 3.8 developed a 4-step methodology to positive performance, using ecosystem metrics as a benchmark to guide what it means to have a regenerative design. We essentially identify a local ecosystem, quantify its performance, and compare that to a company or site or community, and create and implement design strategies to close the gap in performance between the two. So using ecological design is not a new idea, but the exciting part here is that integrating this mindset into a framework that can be scaled across different sites to have ongoing positive effects. So we start by linking the functional needs of the company to those of the community and the ecosystem. That allows us to quantify the gap in performance between the company and the reference site to set aspirational goals. So we can then select design strategies to address those gaps and provide multiple co-benefits. So this shifts our mindset away from doing less bad, something like reducing carbon to reach zero, to a positive goal of increasing the amount of carbon sequestered while increasing something like the pollinator habitat, for example. So what we've created is a methodology that delivers a quantifiable and defensible approach to positive, a locally relevant and scalable framework, and a pragmatic approach that aligns with existing goals. And that provides us the opportunity to improve biodiversity, the planet health and the public health, become a welcome neighbor, and engage employees, improving performance and retention. We recognize that this was a big vision, and to execute it successfully, we would, like nature, collaborate with industry leaders to support the data, design, and implementation opportunities. So in 2019, Biomimicry 3.8 launched Project Positive to demonstrate companies can drive innovation, support climate goals, and engage employees and local communities using a programmatic and data-driven approach inspired by nature to achieve positive performance. So Project Positive is a collaborative of change agents dedicated to raising the bar on what acting sustainably means. So we're working with companies such as Ford, Google, and Microsoft to change what it means to actually be sustainable. And next we'll walk through an example of that pilot program so you can see the specifics of how each of those steps plays out. The first step is looking to high-performing ecosystems nearby to serve as that reference point. So this is one of the unique aspects of this methodology, that rather than setting those ambiguous reduction targets for carbon footprint or water usage, we set numerical goals that are relevant and directly tied to what it means to function well within that local ecosystem. So we look at multiple habitat types to understand the ecological dynamics of place and find champion species that can serve as mentors for the ecosystem services. And then this is achieved through a deep understanding of the local context. So this would include factors like ecological, social, and company aspects. And this is just a visual example to illustrate the amount of detail that's included in the analysis of those reference sites. An understanding of context helps inform the company's key performance indicators across a variety of categories. So once we tie those KPIs or key performance indicators to the ecological performance categories, we can get a sense of the relative performance of potential design interventions as it stacks up across those multiple categories, which allows for comparisons to optimize performance of the system as a whole. So I'll show you a more detailed example of that closer to the end, but one of the important things to note here is that, like nature, each of the design solutions may meet multiple categories or provide multiple co-benefits. So we want to be able to prioritize the design solutions that stack up to meet our functional needs in an appropriate way. So something like stormwater management, where you have both infiltration and evaporation aspects within that, we want to be sure that we actually aren't exceeding the ecosystem performance targets. So for example, we don't want to be intercepting too much rainwater, and we don't want to be releasing that into the environment at higher quantities and higher rates than what the ecosystem would normally be able to handle. The functional needs that are identified based on contextual data can also inform design. So as we look to those champion adapters in the local ecosystem, we can take a biomimetic or nature-based approach to meeting those functional needs in a locally relevant way. And then once we've identified our reference ecosystem and understand the context, we can collect that data and quantify the performance that gives us those numerical targets to work towards. When we've linked our KPIs to our ecosystem functional needs and quantified the reference ecosystem, we can quantify the baseline performance of the building or community and essentially do a performance gap analysis. Then we can solve for that gap by creating design solutions and selecting relevant interventions. So here you can see the baseline performance of the company site is in gray and the reference ecosystem is in green. And we can see that what that performance gap is and set those aspirational targets for our design solutions. And when we shift from looking at targets like zero carbon or a % reduction in water consumption to ecosystem metrics, such as sequestering carbon and using captured rainwater that we then put back into the surrounding ecosystem, those are very different design strategies. So we can create different solutions based on newer existing designs such as rooftop gardens and permeable pavement to match those ecosystem performance metrics. This happens in 2 phases. The first phase is to look at biological strategies to develop design concepts. We can envision multifunctional design strategies to provide co-benefits, and we can begin modeling them throughout the site, moving things around to see where they can have the greatest impact. It's hard to do this with a mask on. From there, From there, we can pull together a collection of existing bio-inspired and nature-based solutions specific to those areas and that site. So this is just a visual example of a subset of possible interventions that includes tracking both the company goals and the ecosystem functional needs, as well as details on the specific bio-intel and the product information that is already available in the market. So here we can take a more detailed look at a bio-inspired solution. This is pervious pavement that has a positive impact on water management by providing the ability of a hardscape to infiltrate water into the soil below, where it can then be filtered and recharges the groundwater while reducing runoff. So these type of systems also reduce pollutants by allowing water to move through the soil, being broken down by microbes and taken up by plants that grow between those paving stones. These pervious pavements infiltrate, treat, and store rainwater where it falls rather than running off into storm sewers, and they can be made by a variety of porous interlocking materials to slowly release water into the ground below, and they can be incorporated anywhere from walkways to light-duty roads. Here's another example. So a roof structure is partially or completely covered with vegetation to convey various ecosystem services such as stormwater management, that can be incorporated in both new construction and also renovation of existing facilities when re-roofing or remodeling. They contribute positively to the enhancement of building thermal performance, thereby saving energy and reducing the site's carbon footprint. Green roofs also help manage stormwater, intercepting and slowing water flow in place, significantly reducing runoff. Additionally, they can increase biodiversity, improve air quality through pollutant removal, sequester carbon, and create visual buffers and noise buffers by increasing sound insulation. So once we've envisioned that collection of design strategies throughout the site and collected a set of solutions for positive interventions, the next step is to model what that positive performance is quantitatively. So we want to choose design strategies that provide balance across all of the performance categories. So the process is really a decision-making tool, solving for the functional needs that enable the site to perform like an ecosystem. Performance modeling gives visibility to the suite of solutions needed to achieve across the performance categories, as those solutions each kind of act as a lever to be combined in different ways and see how those can be combined to affect positive performance. So here I'm showing you the performance model of two possible scenarios compared again to the baseline in gray and the reference ecosystem in dark green. So you can see that the second scenario has a more positive performance overall. We can take a more detailed look at the quantified performance stack up of each intervention. So, excuse me. This is the performance of the previous paving example applied to a parking lot. So the stack up of the previous pavement is in the middle of the chart compared to the site baseline on the left and the reference ecosystem targets on the right. So you can see that this design intervention exceeds target performance excuse me, for everything except water quality and biodiversity support. Given that the intended function of this area is for vehicle parking, we would actually consider this to be a really strong performance overall while still allowing for that intended use. And if we combine this with coverage such as shrubs and trees, we can drive high levels of performance across all those KPI categories. And just for reference, this chart here is calculated on a per hectare basis. Here's the stack up of the green roof example. In this case, there were design limitations to retrofit to an existing facility. So the performance values we see here are a little bit lower than could be expected with earlier intervention, but the solution does still meet the targets for stormwater management and soil quality, while also performing well in water quality, health and well-being, carbon, and biodiversity. Okay, give you guys a second to look at that chart. We can take all of these quantified performance stack-ups together to have a comprehensive understanding of the site as a whole. So that allows us to rank and prioritize the implementation of these solutions from a business case perspective. From there, we can do a business analysis by looking at the investment cost, the scalability potential, the contribution to positive performance, and the corporate goals, as well as the timeline for both the decision-making and incorporation of the strategy into the site design. So this includes financial considerations for operations and maintenance, and takes into account both the return on investment and the equivalent annual cost compared to the baseline and the master plans for the site. So this also includes non-financial analysis of prioritized and weighted metrics such as health and well-being of the people that would be using that space. And then once the designs have been created and decisions have been made, a plan can be put in place for implementation, maintenance, and scalability to future sites. After procurement and construction, this also includes a plan to measure and monitor over time to see how these solutions actually perform compared to those aspirational targets that we set out at the beginning. So in addition to designing solutions to achieve positive performance, this implementation plan is unique in that it also includes a communication strategy to capture a narrative that is locally relevant to employees and communities, fostering reconnection of people to place, supporting employee engagement, and demonstrating the role of the company as a welcome neighbor to that ecosystem. So this communication strategy is also valuable for sharing success stories and lessons learned across a wider sphere of influence, encouraging the adoption of positive decision-making tools and design strategies, both across sites within the company and also within the surrounding community. So I mentioned that this was a recently launched pilot program, and so it's still in progress, but I want to jump a little bit into what the potential next steps could be for further integrating biomimicry beyond just the exterior facilities of a company. So to truly be positive, we also have to look at product innovation and supply chain. So it doesn't help to have a green building if we use that to manufacture harmful products with a heavy transportation footprint. In the same way, we would miss part of the equation if we don't account for manufacturing aspects of something like a zero-emission vehicle. So we start with the facilities and operations because they are the most immediate sphere of influence for an organization to be able to change. This also gives a starting point for the companies to so-called walk the talk, setting an example and demonstrating commitment as they look to further expand that sphere of influence and expand those sustainability goals to employees, to operations, as well as product innovation and out to their surrounding communities and supply chains. So, whoops. I lost my notes. Oops. Okay, so and then when we look to the future of transportation and zoom into that technology level, we can find opportunities to apply this positive mindset to product innovation as well. So obviously we're not the first ones to face any of these design challenges. Of course, nature has those time-tested solutions for functions that we can emulate. So from my perspective, the biggest challenges in battery and fuel cells are energy production and thermal management. So I wanted to share just a few product case studies that can be interesting and relevant from this positive performance standpoint. So this is a case study of a new type of water repellent membrane that can improve the efficiency of fuel cells by a factor of 4. It works in a similar way to a cactus plant, which thrives by retaining water in harsh, dry environments. In order to maintain performance, fuel cell proton exchange membranes need to stay constantly hydrated. Conventionally, that is achieved by adding a radiator, a water tank, and a humidifier to the fuel cell system. But those components obviously take up a large amount of space and consume energy to operate. So this bio-inspired design emulates the pores of a cactus skin, which open in cool, humid conditions and close during hot, dry conditions to maintain optimal moisture levels. So this membrane works by using nano cracks in a hydrophobic coating layer to regulate the water generated by the fuel cell stack itself. So these type of systems can be used to support the operations and positive performance metrics and design solutions that we need to implement both on a vehicle as well as potentially in infrastructure such as water filtration or gas filtration. Another fuel cell example, this is a biomimetic bipolar plate that offers cost reduction and boosts power by 16% while improving water management and reliability. So they're inspired by the branching structure of animal lungs and plant tissues that maximize surface area for gas exchange and allows efficient flow through the system. So in conventional fuel cells, the rate of reaction is achieved through catalysts by rare metals such as platinum, and researchers here have emulated the iron-sulfur structure used by enzymes in the living world, such as those found in cyanobacteria, to catalyze the same reaction at high rates using abundant materials. So aside from reducing the cost and the negative effects of mining operations, as well as the accumulation of trace rare earth metals, using these type of abundantly available materials for energy generation allows us to be more relevant to the local ecosystem. When we look at a waste stream or potential reduction of contamination, we can put these locally relevant, life-friendly chemistries back into the surrounding ecosystem at concentrations that make sense. So if you're talking about a bioremediation type strategy, you have concentrations of materials that make sense for those local strategies. So we've seen that we can use biomimicry and positive performance to inform holistic organizational transformation and to have a regenerative impact across facilities, operations, and product design. So this is a powerful framework that can be integrated into both existing and future operations as a decision-making and design tool to achieve positive performance and life-friendly solutions. So the closing sentiment that I want to leave you with is that Biomimicry 3.8 started these pilot programs with these large corporations to demonstrate what is possible. But to have a positive performance ecosystem, it takes all of us. And I think we've kind of heard that same sentiment echoed across a couple presenters yesterday and earlier today as well. So I want to encourage all of you to think more deeply about the process of innovation and how we can design our products and do our work in a positive way that creates conditions conducive to all life. So that's all I have for you today. I would invite you to visit the website here for more information, and I'll be glad to take any questions if we have time. Thank you.